In this video, I am going to solve the problem 63 from chapter 19. Here we have three questions, so I will read one by one. Okay, so compute the RMS speed of nitrogen molecule at 80 degrees Celsius. The molar mass of the nitrogen molecules is given in the table. So in the first part, we are going to find the RMS speed. So let's we answer one by one. So here I'm going to calculate the RMS speed of the nitrogen molecule, and the nitrogen molecule molar mass is given here, which takes the value of 28 multiplied 10 power minus 3 kilogram per mole. So the molar mass of the nitrogen molecule takes the value of 23 multiplied 10 power minus 3 kilogram per mole, and the temperature they mention here as 80 degrees Celsius. So we have to convert this into Kelvin. So we have to add 273. We got the answer here as 353 Kelvin. And for this, we are going to calculate the VRMS speed. That means the speed RMS, root mean square, speed. So VRMS is equal to square root of 3RT over M, where M is the molar mass, R is the gas constant, and T is the temperature. So I am going to substitute the value here. Square root of 3 multiply 8.314 multiply with the temperature 353 over the molar mass of the nitrogen is 28 multiply 10 power minus 3. I got the answer. So this is our first question, right? So I got the answer here as VRMS is equal to 560.76 meter per second. So this is the answer for the first question. Okay, now we have to go back to the second question. Let's read what is given in the second question. At what temperature will the RMS speed be half that value? So in the second part, we are going to calculate the temperature for half of the value of the RMS speed. So here in the first part, we got the value of RMS speed as 560.76. Suppose if this value will be half, what should be the temperature? So that means here in the second part, we are going to consider the half of the value of the RMS speed, and for that we are going to calculate the temperature. Okay, it's very easy. So let's work out. In the B part, we have to consider half of VRMS. For that, we have to find what is the temperature. So what is the half of VRMS? The half of VRMS is equal to, that means VRMS, here we are going to consider the half of the value. So by that, 560.76 over 2, we got the answer here as 280.38. So for the second part, we have to consider this is our RMS speed, because we have to consider half of the RMS. Where is the RMS? In the first part, we already calculated the RMS. In the second part, we are going to consider the half of the RMS. For this half of the RMS speed, we are going to find what is the temperature. So I have to use the same relation. What is the relation? VRMS is equal to root of 3RT over M. So I have to squaring both left hand side and the right hand side, because we have to discard the square root. By that, this will become VRMS square, which is equal to 3RT over M. And here we are going to find the value of the temperature. So I have to rearrange this equation in terms of temperature. Therefore, T is equal to VRMS square multiply with the molar mass of the nitrogen over 3 multiplied by the gas constant. So now I am going to substitute the value. So here we have to consider the VRMS for this is 280.38 meter per second. We have to substitute here. So by that, T is equal to 280.38 square multiply the molar mass of the nitrogen is 28 multiply 10 power minus 3 over 3 multiply 8.314. We got the answer here as 88.25 Kelvin. So this is the answer if you consider the VRMS as half. Clear? So this is the answer for the B part. Now we have to go for the third part. What is given in the third part? We have to find the temperature again if the RMS speed is twice that value. So here we got the RMS speed as 560.76. Suppose if this value will be double the times, what should be the temperature? So again we have to use this value for finding the temperature. So third part is also we are going to find the temperature. In the A part, we found the RMS speed as 560.7 6 meter per second, right? So in the third part, what we are going to consider, we are going to consider our RMS as double the times of RMS. So double the times of this value. So I have to multiply this value, 560.76. Here we got the answer as 1121.52. So this time we have to consider this is our RMS. So again we have to work out in the same method what we did in the B part. VRMS is equal to square root of 3 RT over the molar mass of the nitrogen. So here we are going to find the value of the temperature. So I have to take the square on both sides, left hand side and the right hand side. By that the left hand side becomes VRMS square. The right hand side the square root will be gone. So 3 RT over the molar mass. Now I have to substitute the value here. First of all, we will rearrange this equation. Therefore, T is equal to VRMS square multiply with the molar mass of the nitrogen over 3 times of R. So this time what I am going to do, I am going to take this VRMS and substitute here. Clear? By that what will happen? 1121.52 square multiply with the molar mass of the nitrogen is 28 multiply 10 power minus 3 over 3 multiply 8.314. So here I got the answer as 1412.0 Kelvin. So we can write in terms of power 1.412 multiply 10 power 3 Kelvin. So this is the answer for the third part. That's it. Thank you.